This kata is called triangular treasure. What do we have to do here? Well, we have a function that takes an integer as an input and we have to return the triangular numbers. And they are called that way because of the equilateral triangular shape that they occupy when they are being laid out as dots, like you see here. But we don't have to return the dots or the pattern of the dots, but only the integers that they represent. Let's go. So when the input is 0, we should output 0. When the input is 1, we should output 1. And when the input is 2, we should return 3. 2 is 3. Then we have 3 that should output 6. And lastly, we have 4 and that should output 10. Let's start iterating and try to find a pattern for integer and then in the range of n. Or let's rename this integer to triangle. Yeah, 1, 0, 1, 2, 3. We should have an extra iteration. So let's add a 1. Yeah. And what happens when we multiply triangle with triangle? Then we have 16. When we have 9, for example, that should output 45. It looks like we have to divide this by 2. But that's not exactly what we have to output. When we have 2, for example, then we miss 1. When we have 1, we only have a half. What happens when we add up 1 with triangle? 1 is 1. 0 should output 0. It is. When we take 2, then we get 3. Okay. When we have 4, that should output 10. Oh, this is exactly what we need. So what we can do is to use this calculation and assign to triangle is equal to this calculation. So let's print it out. What you see here is the calculation which is being assigned to triangle every iteration. And at the end we have 10. So when we return this outside the loop, we should have the correct answer. And then we have 9. Yeah, 45. Then we have minus 9. That should output 0. There we have a problem. Oh, what we can do is to define a condition. So if n is more than 0, and in all the other cases, we should just return 0. Yeah. Let's put in 9 again. Yeah, that works out. Well, let's try this. It timed out. Maybe we shouldn't loop. What we actually can do is the following. We can replace triangle by n and return this immediately. That loop didn't serve anything, actually. So when we return this, it should work out as well. But of course, we have to use a condition. Yeah. If n is more than 0, else we return 0. Let's attempt. There we still have a problem. Maybe we should floor divide or something like that. Let's attempt. There we go. It's just a problem with the fractions here and there. But we got there. Hope this has been useful anyway. And hope to see you in another video. Thank you for watching.